In this lesson, we're going to talk about angles in standard position. An angle in standard position is one in which the initial side is the positive x-axis. So that's very important. Standard position, we're looking at the positive x-axis. So the origin is the vertex. And so we have three examples here. So we see the initial side, positive x-axis. We go counterclockwise, and we get to the terminal ray or terminal side, and that's where we get a 45-degree angle. We can see the same thing here. If we rotate to the left, we get the terminal ray here, and that would be a 130-degree angle approximately. In the final diagram then, we can see as long as we start on the positive x-axis, we can also rotate clockwise here. And clockwise tells us that we have negative, so this is negative 120, but we can also take this angle and go counterclockwise, which would give us a 240-degree angle, and those are coterminal angles because they start both at the positive x-axis and they both finish at the same place. So we talked about that in the previous lesson. Quadrantal angles, those are angles where the terminal side, so it finishes, so it ends on the x or y axis, and those give us special angles. We have 90 degrees if we start on positive x and end positive y. There's a 90-degree angle. We can keep going and end on the positive or negative x-axis. So don't forget, we're always starting on positive x. If we end on negative x, that's 180. If we end on negative y, so straight down, that's 270. 360 if we go from positive x all the way around back to the positive x-axis, that's 360. And if we keep going, we get to positive y again, that's 450, etc., etc. Or we can do all the same things except backwards and get negative 90, negative 120, etc. The terminal side, if the terminal side is in the first quadrant, the angle is called first quadrant angle, and we haven't mentioned quadrants, so let me just sketch the axis here. We refer to each of the sections in our Cartesian coordinate plane as quadrants. So here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if the line or the terminal ray is somewhere in quadrant 1, it's called first quadrant, somewhere in quadrant 2, second quadrant, etc. This leads us to a quick discussion about reference or related angles, and this is really important when we start talking about angles that aren't found in triangles. So if we start talking about any angles, well, an acute angle that's formed between the terminal arm, so where the angle ends, terminal arm, and the x-axis, and notice it doesn't say positive x-axis, it's just where the angle finishes and the x-axis, is called the reference angle, or related angle. I'll call it the reference angle. Coterminal angles have the same reference angle. And that's a very important statement because we're going to use that when we talk a little bit more about trigonometry. For these examples then, we want to find the reference angle. So reference angle is the angle between the terminal arm and the x-axis. So if we sketch these diagrams for these angles, we have a 50-degree angle, so 50 degrees is in quadrant 1. So there's the angle, 50 degrees. Well, the reference angle then, reference angle, often called alpha, is going to be the acute angle from the terminal side, so where it stopped, to the x-axis. So the angle from here to the x-axis, well, for a quadrant 1 angle, which this is, it's actually the same. So in this case, it's 50 degrees. So this is the reference angle and the angle. Sometimes we say theta and alpha. So in this case, we want to determine the reference angle, and again I'll call it alpha, for the angle theta equal to 120. Well, let's sketch 120. That's in quadrant 2, because it's between 90 and 180. And that angle starts here and comes up here. Now, if we want to do the reference angle, we need the angle between the terminal arm or terminal side where it stopped and the x-axis. So the shortest distance from that side to the x-axis is right there. So in this case, this is the reference angle. This is alpha. How do we find that? Well, we know the straight angle is 180, and we know this angle here is 120. So the difference, 180 minus 120, gives us 60 degrees. And so that's the reference angle. That's the angle between where the angle stops and the x-axis. For an angle of 320 degrees then, we have 320, which we start here, and it is somewhere in quadrant 4, between 270 and 360. So this is 320 degrees. And the angle then, the acute angle between the x-axis and the terminal side would be this angle right here. And we always refer to it as positive. The reference angle is always positive because it's just referring to the space between where the angle stops and the x-axis. So in this case, this distance then has to be the full circle, which is 360, minus however much this angle was. So in this case it's 320, and that gives us 40 degrees. And before we finish this lesson, I'm just going to give you a quick thing to remember here. If we're talking about an angle theta and a reference angle alpha, so this is the angle theta, reference angle alpha. In quadrant 1, alpha is equal to theta. In quadrant 2, which is what we saw in example 2, we get alpha is equal to 180 minus our initial angle, or alpha, or theta. In quadrant 3, we're going to take our angle minus 180 to find our reference angle. And in quadrant 4, which we just saw in example 3, theta is going to be, or alpha is going to be 360 minus theta, whatever our angle was. So that's a way to remember, if you want some way to find the reference angle, alpha, if you're given an initial angle of theta. That's where we'll stop this lesson. In the next lesson, we'll start talking about right triangles and defining some trigonometric terms. Until then, if you have any questions, make sure you get help as soon as possible, and we'll see you in the next lesson.